Hey guys, welcome to my first ever long form video. Today we're going to be breaking down vasoconstriction, vasodilation. How does it happen and how different drugs and receptors interplay into this process. So first we're going to start with the physiological processes that are going on within our body that are responsible for contraction and dilation of these veins. There's three of them for us to consider today. The first one is going to be the interaction of calcium and calmodulin. The second one is going to be the interaction of cyclic AMP and your GS receptors, and the third one that we have to consider is going to be your GMP, cyclic GMP, and how it's involved with nitric oxide to trigger a relaxation pathway. So first we're going to be discussing this calcium calmodulin pathway. So what exactly is happening in this pathway? This is the pathway to trigger contraction. We all know how important calcium is for muscle contraction, right? So in this pathway, calcium is going to enter into your cell, is going to bind with calmodulin. This is the key difference between smooth muscles and striated muscles. In striated muscles, contraction is mediated by unmasking actin via calcium, and in smooth muscles, contraction is mediated by binding calcium to calmodulin, which then phosphorylates your myosin light chains, which is your myosin chain. And when you phosphorylate the myosin chain, it can raise and attach to the actin. In smooth muscles, the actin is not covered by troponin. So the gateway between the signal, calcium entry, and contraction is going to be the phosphorylation of your myosin light chain, not the unmasking of actin. This is the key difference. Now, coming to the drugs at play here, obviously we have drugs that are going to impact your calcium entry. The first one are going to be your, so we're going to have to think about this in terms of the receptor and in terms of the direct drug. The direct drug is obviously your calcium channel blockers. If you block the entry of calcium, you're going to block this complex formation. You're going to block the formation of myosin light chains, which are phosphorylated, blocking contraction, triggering dilation or relaxation. Now the second pathway to think about is via your beta receptors. So your beta receptors are going to phosphorylate your calcium channels, which is going to increase the calcium influx into the cell, increasing this process, increasing the strength of contraction. So if you give beta stimulants like adrenaline, noradrenaline, beta 2 stimulants, it's going to cause vasoconstriction, not vasodilation. Now we consider the next type of drug here, which is going to be your beta blockers. If you block this process by reducing calcium entry, you're going to reduce phosphorylated myosin light chains, reducing contraction, causing dilation. Now this pathway is clear. Let's move on to the next pathway and the drugs involved in it, which is going to be your cyclic AMP pathway. Now this cyclic AMP pathway is directly activated by your G protein, which is coupled with your beta 2 receptors and your beta 1 receptors. In your vasculature, your beta 2 receptors. Now, how does this pathway work? You have the stimulation of your beta 2 receptor, stimulation of your G protein, causing the increase in activity of adenyl cyclase, which is going to increase the conversion of ATP into cyclic AMP. Now this cyclic AMP is going to activate protein kinase A. Protein kinases phosphorylate molecules. It's going to phosphorylate myosin light chain kinase. What does this kinase enzyme do? It phosphorylates myosin to a phosphate group, allowing for contraction to take place. But the thing with these GS and adenyl cyclase is that cyclic AMP increasing pKa, phosphorylating your myosin light chain kinase, actually inactivates it. If it inactivates it, it prevents the phosphorylation of myosin, preventing smooth muscle contraction, resulting in vasodilation. So that's this entire pathway. Now let's bring the drugs into the picture. Now the first drug we're going to consider directly to your beta 2 receptors is your beta blockers, the non-selective type. When you give them beta blockers, it's going to block the activity of this protein kinase A. It's going to block the phosphorylation of myosin light chain kinase, keeping it active, phosphorylating myosin, causing contraction. That's why beta blockers cause vasoconstriction, not vasodilation. Now the second drug to consider in this pathway is going to be a drug that prevents the breakdown of cyclic AMP to AMP, and this process is mediated by phosphodiesterase 3. That's the enzyme that mediates it. So it stands to reason if we block this process, It'll reduce the cyclic AMP. Reducing the cyclic AMP is going to reduce your protein kinase A, which is going to reduce the amount of myosin light chain kinase from which the phosphate group is removed. So it's going to keep more myosin light chain kinase phosphorylated, and remember, the phosphorylated state is the inactive state. So myosin is not attached to a phosphate group, keeping it also inactivated, preventing contraction, resulting in vasodilation. So I hope that's clear. Your PDE3 inhibitor drugs cause vasodilation, your beta blockers cause vasoconstriction, and that's mediated by this physiological pathway. Now moving on to our last and final pathway to consider, it's going to be your nitric oxide and GMP pathway. And there's also some receptors involved here. So first I'll tell you the pathway and then I'll bring the receptors into the picture. So your endothelial cells have an enzyme called nitric oxide synthase, which converts arginine to nitric oxide. Arginine, the amino acid. The nitric oxide moves freely across the membrane between the endothelial cells and the vascular smooth muscle. Now this nitric oxide is within your vascular smooth muscle. What does this nitric oxide do here? This nitric oxide then binds to an enzyme called guanyl cyclase. What does guanyl cyclase do? Increases the conversion of GTP into cyclic GMP. What does cyclic GMP do? It activates protein kinase G, which phosphorylates your phosphatase enzymes, activating them. So it activates phosphatase enzymes. What do phosphatase enzymes do? They cleave the phosphorus group from proteins. Where does this act? It's acting on your myosin light chains, removing the phosphorus group from them. Now coming to the first concept I explained, if you remove the phosphorus group from your myosin light chain, it terminates the contraction, because a phosphorylated myosin protein is what lifts up, attaches to the actin and causes contraction. So if I remove this phosphorus group, it's going to terminate the contraction. So this entire pathway, by removing the phosphorus group from your myosin light chain, causes relaxation of your blood vessel, causing vasodilation. Now we are going to bring in the receptors that can trigger this pathway. So in your endothelial cells, your muscarinic type 3 receptors, your histamine receptors and your bradykinin receptors can activate this conversion of arginine to nitric oxide, activating the pathway, giving you vasodilation. Now coming to the drugs involved in this pathway, obviously if I'm going to increase nitric oxide, I'm going to increase the action of phosphatase enzymes down the line, which is going to increase the cleavage of the phosphate group from myosin light chain, causing relaxation. Now what are these drugs that increase nitric oxide? Your nitrate drugs. These are precursors to nitric oxide. So if I give more precursor, increase synthesis of nitric oxide. And what are these drugs? You obviously have your nitroglycerin, your nitroprusside, your hydralazine. All these drugs come into play here. Now our next class of drugs to consider is going to be drugs that increase the cyclic GMP. If I increase the amount of cyclic GMP, I increase protein kinase G activity, I increase phosphatase activity, and I increase the cleavage of this phosphorus group from myosin light chains, terminating your contraction. So now our key takeaway here is that if I increase cyclic GMP, I increase vasodilation. And now how do I increase cyclic GMP? There's an enzyme that breaks down cyclic GMP. That enzyme is phosphodiesterase 5. So if I block this enzyme's action, I can increase cyclic GMP, increasing vasodilation. And how do I block this enzyme? I block it with the help of my FILs. What are FILs? Phosphodiesterase 5 inhibitors, your tadalafil, sildenafil, your Viagra. All these drugs are phosphodiesterase 5 inhibitors, which are going to mediate the cleavage of the phosphorus group from your myosin light chain, causing relaxation of your blood vessels. Now the last part, what are your takeaways from this session? These are the drugs we've discussed, and real quick, what they do, how they act. Your beta blockers are going to reduce cyclic AMP, reduce protein kinase A, reducing the phosphorylation of myosin light chain kinase, which is going to increase how much myosin is going to be phosphorylated, increasing contraction. That's why beta blockers cause vasoconstriction, because they block beta 2 receptors. Now the second drug of consideration, your PDE3 3I, which is your phosphodiesterase 3 inhibitors. What do these drugs do? They increase cyclic AMP. An increase in cyclic AMP is going to cause vasodilation because it's going to cause less myosin to be phosphorylated, because it inactivates myosin light chain kinase. Now our next drug, nitric oxide, cyclic GMP pathway, activation of phosphatases, which is going to cleave the phosphate group from myosin, causing dilation. And nitric oxide, actually your nitrate drugs, your nitroprusside, hydralazine, all that. Now your phosphodiesterase 5 inhibitors, what do these drugs do? They increase cyclic GMP, same pathway again, causing vasodilation. And the last one, calcium channel blockers, reducing the influx of calcium into the cells, reducing contraction, causing vasodilation. If you enjoyed this session, consider joining my live session that I'm hosting this Saturday. If you're interested in that, please send me a DM on my Instagram account. The link's going to be in the bio.